Okay, this problem actually poses a pretty interesting problem for us, the way that we learned area of a hexagon. So it basically just tells you the area of a hexagon is 48 root 3. Okay, and it says find the length of a side, then find the area of the inscribed circle. So I put this circle here. This is the inscribed circle, but I took it out for a second just to show you what we're doing. So we said originally the area of a hexagon is 1/2 the apothem times the perimeter, but I'm going to propose a different way to find the area of a hexagon. And this is actually the way that we teach in CP, because we really only talk about areas of hexagons. But in a hexagon, if you split this thing up, you actually create 6 triangles that are all equilateral. And that's going to be pretty powerful in order to be able to find the side length of this particular one that has an area of 48 root 3. So I'm going to propose the fact, since the hexagon is basically 6 triangles, all equilateral, all congruent, it's going to be 6 times the area of one of them. And the area of one equilateral triangle is side squared root 3 over 4. So that's going to be the way I find the area, or the side length of this hexagon. So since I know that that equals 48 root 3, this is going to be pretty helpful. So I can divide both sides by 6, basically getting side squared root 3 over 4 equals 8 root 3. I could times by 4. This gives me side squared root 3 equals 32 root 3. I could divide by root 3. Side squared ends up being 32. So then when I square root this, I see that 16 comes out 2 times. So the side length is actually going to be 4 root 2. Okay, so that's going to help me figure out the area of the inscribed circle. So if the side length of this hexagon is 4 root 2, then I know that the apothem, which is actually going to be the radius of this circle, is always in a relationship of half the side root 3. So it's going to be 2 root 2 times root 3. So the apothem is actually going to be 2 root 6, which is going to be the radius of the circle. So the area of the circle, which has radius 2 root 6, is just pi 2 root 6 squared. Well, 2 root 6 squared is going to be 4 times 6, or simply 24. Is that right? Yeah. So 4 times 6 is going to be 24. So the answer is actually, this area of the circle is going to be 24 pi. So I just checked that's right, so we can move on without having to redo this one. Okay, good, that is right. All right, here's 35. All right, a square is inscribed in a circle. Its apothem, the square's apothem is 5 root 6. Okay, so that's what we got. Find the circumference of the circle. Find the circumference of the circle inscribed in the square. Okay, I could actually do part B right now, because we just saw if I inscribe a circle inside a regular polygon, then the apothem of that regular polygon is actually the radius of that circle. It's actually easy. If the circumference of a circle is 2 pi r, I already know the radius of that little circle inside. So the circle inscribed in the square has a radius of 5 root 6, which was actually given to me at the start of the problem. So it's 2 pi times 5 root 6, or 10 root 6 pi. Okay, so that's the answer to part B, and that's why that one's pretty straightforward. The other one, let me take this out for a second. The other one, the circumference of the circle, I got to use my 45, 45, 90, because I need to figure out what this length is here. Well, if this is what I need, and that's the radius of the circle, then it's a 45, 45, 90, where the leg is 5 root 6. So 5 root 6 times root 2 is actually going to be 5 root 12, which isn't pretty, but I can break that down. 5 root 12 is the same as 5 root 4 root 3. I could break root 12 down, so it's going to be 5 times 2 root 3, which is going to be 10 root 3. So I see the radius of this circle is actually going to be, more simplified, 10 root 3. So therefore, when I find the circumference like I did the last time, it's 2 pi r, or 2 pi times 10 root 3. So I got basically 20 root 3 times pi, or 20 pi root 3 when it's all said and done. So part A is 20 root 3 pi, part B is 10 root 6 pi. All right, last one we're going to look at before we switch it again The surface area of a regular triangular pyramid whose edges are all 4. So since it's regular and it's triangular, okay, it's a tetrahedron. Basically what you got are 4 sides, all equilateral triangles. So the area of an equilateral triangle is side squared root 3 over 4. And because this is a 4-sided figure where every side has that area, it's just going to be 4 times that, which is actually kind of cool because look at the 4 is going to cancel out. So I end up with just side squared root 3, which is going to be 4 squared root 3, which gives me a surface area of 16 root 3. I believe this was a test question that we looked at, and it was actually very simple if you understood the problem. So